The stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Yeah, we are in. Hello, everyone, and welcome to days, I want to say 11, but probably a bit of 10 and 8 of Advent of Code.
Yeah.
Hello to Nick here on the chat. Hello to David. How are you all doing?
Very well. Excited for another day.
Yes, and I am a bit late because besides puzzling with Advent of Code, I was also trying to get this modem working. And
Oh.
yeah, I had to do a long press, long press, complicated stuff. But here we are. And neither of us managed to not work on Advent of Code since yesterday. So, David, what are your news? What do you have for us?
All right. Well, if you come to the my editor, I just shared that link with you. And share your screen. By the way, your internet does seem better today, which is good.
That's good.
I'll give you a quick share. I'll talk you through what I've done.
I am clicking on the buttons. Oh, and I don't think you mean the button for the Adam Buxton podcast. So.
Oh no, sorry. That was I was going to share that with you. That was just because he makes really cool jingles for his podcast, and they're really, really funny.
Okay.
So I don't know. You might have some inspiration, but yours are really cool anyway. But yeah. So are you in VS Code?
I don't have a link,
Yeah.
or is it a link that you sent before above? Ah, okay. I think it may be this one, and
I did send it today. Might even be the same link, to be honest.
Okay. All right. I got the right link because it's getting in, and I would trust. Okay. Oh no, it gave me an error message. Let's try again.
Okay, let me share it again.
I'm trying again.
I don't know if this link is any different. It's not easy to see if it is different.
Joining collaboration session. The live share host is currently offline. This usually occurs due to the host machine being in sleep mode, blah, blah, blah. Okay, let's try the new link. By the way, speaking of sharing your machine over using Visual Studio Code, same error. This collaboration session is no longer active. Please check the link.
I've restarted the
Okay.
session so that
There is a feature in Visual Studio Code that I never saw, and I never saw anyone talking about, but it is amazing. It's super cool.
Oh yeah.
Yeah, I will share. I will share my screen here on Skype because I think that will come in handy anyway. And then I will point at the feature that I'm talking about. See over here in the bottom. Where is it? It's not available in this Visual Studio Code window because I am in a live share. But see here on this on the bottom, this little antenna. It's for port forwarding. So you're running your local server on port 3000. You can create a port forwarding for the world to see your server right from Visual Studio Code. You don't need local tunnel, ngrok, an SSH tunnel, any of that. Visual Studio Code does that. Isn't that amazing? I didn't know it did that.
Wow, but it does create a local tunnel?
It creates a local tunnel for you. Yeah, it's a Visual Studio Code local tunnel feature.
And it's a public link?
It's a public link, yeah.
Wow, that's really cool.
It is
yeah,
really cool. And it has been sitting there forever. It's not an extension, it's a native thing.
That is actually something which should definitely be visible with Visual Studio Code sharing, because the work that we're doing now, it's actually pretty practical to do VS Code sharing, because that we only have the terminal as the output, but if you have a browser that you're trying to look at the output, you need to actually share that port, don't you?
Well, I suppose that I cannot open a shared port on your machine, which stands to reason, but you probably have this button and you could share the code with LiveShare.
Yeah, that's true. I can. Yeah, I can.
The same way that you have to opt into sharing the terminal, you could opt into sharing your server. All right, what do you have for us? I see a data class
now. All right, I'll share. I've come from the top. What I've done, if you'll follow me, is I've made abstractions, because you love abstractions. No, I'm just joking. But yeah, so pipes, I thought that was a great name, so I stole it. And then, yeah, all we have here is a cell, which it's just convenient, so we can call .row and col easily. The board and the starting cell, I just made the starting cell into a list comprehension. So we get the first one where the column, or this should probably be called cell, maybe, is S. And then next is just an iterator, so it just gets the first one from this generator here, which is kind of cool. So that's the starting cell. And then I implemented this function called move, which takes a direction as a string, and then indexes into this, and then does the moving, and then if it's out of bounds, it will return null or none. So it's just a little bit handy way of doing this. And then the last abstraction is a node for finding the path. I'll come back to explaining what this is, but basically I decided that I wanted to go ahead and do my breadth first search implementation of part 1, because I felt like I could have got there and I was so close. So that's what I did, and I finished that off. So basically you have these starting cells which have an initial, basically their previous direction. They always store their previous direction, so you know which way they should go when you check their pipe. So you have these starting nodes, and then you just pop off the first one, and then if you've already seen that node, then that means you've hit a loop. And then you return the furthest node, and then you output the distance.
It's very niche that because you are doing a breadth first search, when you find the loop, you are at the furthest node. Cute.
Yeah. However, this is the only line which kind of caught me out, really, was adding this particular scene one. You can only, because if you can reach a node and then realize, I can't actually move from that node, so you shouldn't mark it seen until you can actually move from that node. So maybe I should have moved scene somewhere else, but yeah, that's where I got to. So that's just part 1, but I agree that your method of doing things is much simpler, especially as I reread the description, and actually the description says that there's only one loop. So as long as you find one loop, then you're good. You can just exit the program. So I rewrote it again.
So it's not the case that there could be 2 loops, one larger than the other.
No. No, there's only ever one.
Convenient.
So I have this start direction. It's very similar to the way you did it, except it uses my abstractions. So it gets the character. If it's this lovely Python ternary, if it's the starting character, then use the start direction. Otherwise, get the direction from the previous direction using the pipe.
Okay.
And then you just walk it through until you reach the start cell, which I think is quite expressive, and then you've found the loop. Otherwise, if there is no next cell, i.e. you try to move in that direction, or there was no direction to move in, then it's a dead end.
Okay.
So my thinking for part 2 is described up here.
Find the path from S to S, and probably accumulate all nodes on the way. Find cells connected to the wall and not to the path. So if I have like a vertical pipe, we are talking about the right and the left hand side cells, because they are connected to the wall, but they're not part of the path.
Yes.
Then flood fill from those outsider walls, and now find a cell on the path next to an outsider. Walk along it, always filling the inside. Now find a cell on the path next to an outsider.
Yeah, so what we'll do is we'll have flood filled all of the outsider cells. So what you'll have is you have the path and you have the outsider cells. Now I'm going to go through all the path cells, and I'm going to find one where the path is next to an outsider. What that allows me to do is, okay, if I know where the outside is, that means on this particular node, this particular cell of the path, then I can just walk along the rest of the path, keeping track of where the outside is and fill on the inside. So any nodes which are on the inside and not on the outside and are not part of the path, so they're just unmarked cells, fill them in as insider cells. So I have this concept of outsider cells and insider cells, and the path is part of the insider cells, and you can always just deduct the length of the path from the insider cells.
So how do you know when you are beginning that, let's say you are beginning and you see a pipe, a vertical one, and you can go to the right or to the left? How do you know that the right is the inside and the left is the outside, or vice versa?
So I haven't quite got to that point yet.
Okay.
But if you're on I mean, we could go to Excalidraw. Might need a new link. But if you know where, if you know on that node where the outside is, if your current node, you know where the outside is, it stands to reason that you can always keep track of the outside. The next node you go to,
yes,
you just, if it's based on whatever pipe it is, you just need to tell it, okay, the outside is on this side and this direction and this direction.
Yes.
So therefore,
once you figure it out for one pipe, you know for all of them, because you are just, let's say that you're on your pipe, you are going north, and the inside is on the right. Then if you make a left turn, then you know that the inside is to the north. But the problem is, how do you know that to begin with?
Yeah, so that I've got here. So I will just quickly walk you through. These parts are not so interesting. So, like I said, this is just using your method for finding the path from the start. Then I just find a cell connected to the wall and not to the path. So I'm absolutely sure this is an outsider cell. So this is just not. So yeah, this is just checking that, you know, one away from it is on the wall, and then it's not on the path. And then I found my first outsider.
Okay.
And then I just, or actually first outsiders, I find all of the ones that I can be guaranteed, and then I flood fill, because they might not all be connected, of course, right?
Yeah.
So I want to fill out as much as possible. This is a simple breadth first search where I go through each direction, I move to the next cell, and then I keep adding it to the outsiders. If it's basically not in the outsiders and it's not in the path. Finally, this is where I find my first node, which is my first node, and I find out where the outside is relative to this node. So I've redefined node, which today I learned that you can redefine classes, which you can't do in JavaScript, I don't believe, but you can in Python. Just a side note, in JavaScript you can do like f like this. You can't redefine f again like that. I don't think. You can't do this, but you can do this.
Yeah.
Which is kind of crazy, but anyway. So you can redefine functions somehow, but anyway, I don't think you can redefine classes.
Well,
in JavaScript,
I suppose using the same logic to write some JavaScript here, if you have a class node, it stands to reason that you would be able to do this, right?
Yeah, probably, yeah. That's a good point.
Carry on.
Yeah, side point. So this is my simple way of checking. So I'm going through each cell in the path, and what I want to find is just one cell which is next to the outside. So the simplest one to think about is it's labeled as outside up, and then it's a left-right char. Therefore, I now know that the outside is up, and I can just start walking along it, and I say the previous direction is left, and I can just keep going along it. I think that's sufficient. As long as there's one of those in the entire map. I've done it for if it's down, it's down. If it's left, it's left. If it's right, it's right. Now, if you hit a corner one, it's also possible to work it out where the outsider is, but it's a little bit more complicated, and I'm pretty confident we're going to find at least one of these outsiders. So before you rigorously test me on whether this logic makes sense, I just wanted to show you one more thing, which is that in the terminal, I made a little visualization, I guess. So you can see here, this is the board, and these are the outsiders. So the outsiders are labeled with all the X's, and then this is all the path nodes, and you can see actually that's the inside, like probably that section on the inside, which is not an outsider section,
okay,
is the enclosed loop, but we don't know whether it's enclosed properly or not. Now this strategy is much less smart than your rule of two kind of thing, but should work.
Yeah.
Do you agree with this, I suppose?
I have a hard time making up my mind about it.
Let's go to Excalibur.
Okay, we can. Will you share a link with me?
Yes.
Okay.
Let me find, where do I share?
Oh, Nick's version is animated.
Oh, even cooler.
Nick is way ahead of us in this game. Right, I am in.
Okay, so I want to look at these ones over here.
I'm following your cursor.
Yeah, so these ones. So if you imagine this is the node that we're looking at. If it's one of these. Let's make this. If it's one of these pipes, then we can be sure that either side, and it's on the path, we can be certain that those two are both going to be on the path, right?
Correct.
And if it's up, then we know that the outside is up.
Well, how do you know that the outside is up? That is my question.
Because we've already flood-filled the outside.
Ah. Okay.
So we've labeled this as the outside.
Okay.
So that's how we know.
How did you do the flood filling of the outside to begin with? I think I missed that bit.
If we go back to VS Code, that's this section here.
Okay, what is the logic?
So we find the first outsiders. So these are outsiders that we're confident are outsiders. The way that we can confidently identify them is that they're at the edge of the board and they're not on the path.
Okay, that is easy enough. I see that, yes.
So then we start with these. What we want to build, our final output, is the outsiders. So we're going to flood fill and keep this set up to date.
Okay,
and we start
that is easy enough, but my question is, how does that address the case of...
It doesn't do all of the outsiders.
Yes, I specifically, I think that it does not do these outsiders here, right?
It won't. It won't do those.
It will do those. It will not do these outsiders.
Correct. It won't do all of them.
All
it
right.
will just do like a good portion of them. Enough so that we can work out where the inside is and where the outside is. That's what it's for.
I see. Interesting. Okay, with that, I can continue with your explanation.
Yeah, and that's so as long as we are confident that we can find this scenario, then yeah, we can be confident that like this scenario, then we can be confident we know where the outside is, and then we can just walk along the path, and then anything which isn't marked, it's very possible that actually we find some more, path things right here. So this is a separate example.
Mm-hmm.
Well, actually, that would be even better if I just move these. So it's possible that it's right next to a path, right?
Yeah.
Like that. But it's also possible that we have some unmarked, let's make these orange, some unmarked cells here.
Mm-hmm. And those would be inside.
Those would be inside, and we know they're inside. So as we go along the path, if we encounter anything which is on the inside, i.e. not on the outside, then we can simply go ahead and fill them in as insiders.
Mm-hmm.
And then anything which is left at the end, which is unmarked, must be an outsider.
Mm-hmm. I agree with that. All of that seems not only very sound, but very similar to what I did.
All right. Do you want to show me what you did first?
Okay. Yeah, I can do that. So can I just start drawing here in the same Xcali draw? Because I want to present the idea first.
Sure.
And I suppose you can follow my cursor to know where I am?
Yeah.
All right. So in that case, yeah, we are around the same region. So my idea is, first, let's find the path of the longest loop. As we are finding the path, we will accumulate a set of nodes to explore. The set of nodes to explore is, when I am beginning this, I want to accumulate the nodes that are to the right and the nodes that are to the left. And I don't know if the nodes are inside or outside. I know that they are to the left and I know that they are to the right. And I can always do that because if I take one of these turns, then I know that the nodes are going to be down here and the other nodes are going to be up there. I can always just take the nodes that are to the left or to the side because I have not only the kind of pipe, but I also have the direction that I'm going in. That is part of the algorithm for finding the path to begin with. In the end, I will have this...
Sorry, what? One sec. So how do you know which ones are inside and which ones are outside?
I don't yet. I just know that they're to the right and to the left. I don't know if they're inside or outside. But I will keep doing all of this and...
Arbitrarily, yeah.
Yeah, I will just be finding a bunch of nodes to explore. And I guess in my drawing, I'm kind of misleading because I'm not finding interior points like that. I'm just finding points next to the wall as I'm visiting the wall.
Oh, okay.
And similarly for the outside wall, I will be finding dots along the wall that I need to explore.
And will you keep expanding the is that your plan? To be like a little onion thing?
So yeah, exactly. My point is that I will be first collecting these separate sets of nodes to explore, the right set and the left set, and I literally call them the right set of nodes to explore and left set of nodes to explore. And then I will explore them separately. So let's start with the blue one, for instance. So I'm going to explore this node. Is it in the path? No, it's not. Is it in the edge of the board? No, it's not. Okay, so I count it in. Then I will go to its neighbors. For instance, the right neighbor. Is it in the set? Yes, so stop. Is this one in the set? Or sorry, in the path, I should say. If this one is in the path, then don't continue going in that direction. Then is this one in the path? No, so continue exploring. Is this one in the path? Oh, it's outside the board. I ran over. This x is less than 0. So yeah. I have detected that left, or in this case blue, is outside the board. Abort mission. Bap, bap. Okay, try again with the right hand side. And you do the the flooding algorithm, and it will find all the interior of the board. So the way that it detects that I'm inside or outside is by trial and error. And it could very well be that the puzzle was actually like this being the start point and this being the path. And in this case, if I again start by going up, then my left hand sides are the interior and my right hand sides are the exterior. And again, I will just try and find out. If I try the reds and it turns out that I reached the edge of the board, it means that I was on the outside.
I quite like actually calling them red and blue rather than left and right, because although it might be easier algorithmically to say left and right if you're traversing in a particular direction. What's going to be tricky is keeping track of where's the left and where's the right as you move through things, but that's okay. But I like the idea of red and blue because it's like I'm just labeling them at this point, and then afterwards I'll decide which is which. I think that's really cool. And I also feel like your solution might, I don't know, imagine that there was no outside. It was just totally filled with paths and there's like an inside bit. I think your solution would still work and mine wouldn't.
Well, if you think about it, yeah. I was gonna try and argue that your solution would work as well, but no, you would have no anchors to go off of.
Yeah. I mean, I could still label it as any path. What I could still do is say like any elements which have any path elements which are actually on the edge are also considered to be like the outside is on the edge kind of thing. So I could extend it. I probably don't need to do the step. If there are some path elements which are on the edge, I don't need to do the step where I flood fill from the edge.
Yeah, and in your case, since you have this issue of you need some anchors at the borders, you could always just, and I guess this is what you're saying, the solution that we saw probably for the first couple puzzles using VMscript, where they pad the board with empty tiles all around.
Yeah.
And that sidesteps the issue. So, okay, we have very similar ideas, but I fleshed my idea out, I implemented it. I tried with the test boards and it worked, and I tried with a huge board and it did not work. So there is some edge case that I haven't addressed. And your state of affairs is even before that, because you haven't really fleshed out your solution yet, right? You haven't implemented it fully.
Yeah, I haven't got to the stage where I'm going through each node. I did do like a variant which didn't work, so I abandoned that and I was like, oh, this solution will be simpler.
But I have other news. Exciting news. Remember problem day 8?
Yes, let's discuss that, because I also thought about that, but go on.
Yeah, I didn't think about it at all. What I did is I left the code running overnight. The naive code, I left it running overnight, and let's open it.
How did you leave it running, by the way? Because I had issues with that, because it just would automatically go to sleep.
This is gonna be hilarious, isn't it? Ah, no, it's here. Nope, this is gonna be hilarious. I left it running overnight in a Visual Studio Code window that has been replaced when I joined the live share.
You don't have any other windows?
Nope.
Oh, no.
Let's see if there is any other node process running. But I guess it has been swallowed by the live share. Yeah, everything I see here is related to Visual Studio Code itself, not to my program running. And I have re-implemented it in Node because you didn't share the code, and I thought it would be faster to just re-implement since the code was so simple. And it was very fast to re-implement. But last time I checked, which was before the stream, the code did not finish running. So the naive approach does not finish running after one full day. So,
it doesn't finish. Yeah. So mine, I got that. That was my result as well. How did you leave it running, by the way?
Well, I opened a terminal, I started the program, I never closed the lid, and my computer is set to never go to sleep.
Yeah. I should change that setting, but I kind of like it. Okay, so if you follow me, then I did a little bit more thinking about how it could work. So basically, if you remember this diagram,
Yeah.
so this section here is the offset, and then here is the repeats.
Okay.
Offset, repeat. So it's described by this formula. It's the cycle offset plus the cycle length times the steps. I is what we're after, where I aligns for everybody, right?
Yeah.
And then it's going to be plus the end node offset within the cycle, because actually, whilst what we want to repeat is the cycle length, we actually want to know about the end node offset within the cycle. But that's fine, just ignore that. This line is just to say it's a simplification. If we can work out how to do it for cycle offset plus cycle length times I, it'll be easy to add.
Yeah, in fact, I fully don't understand at all what end node offset within cycle is. So I will ignore it.
So like, this is the cycle length here, this length.
Yeah.
And then the end node is not at the end of the cycle, it's somewhere here. Right?
Ah, I see.
It's like somewhere within the cycle. So there's like some offset that we need to add or take away to get it to the offset within the cycle get to the end node.
Okay.
And there's only one end node in the cycle, so yeah, that's just like a fortunate thing about the inputs that we were given.
Okay.
But it could work if we had multiple end nodes as well, like this. It would work fine as well, but
hang on. So you are interpreting this diagram differently. You are putting the pipes where the cycles start.
Yeah.
I was thinking of trying to find, or actually, I was thinking of putting the pipes where the end nodes are.
Yeah, I mean, it's the same thing.
Okay.
In a way, Leandro, because you could just say like this is where the end nodes are, but then the end is going to be some hidden thing in here. You know what I mean?
Yeah.
But like, it's the same thing. It's the same thing. So that's what I kind of wanted to get to, is just like, if we can work out this. So this is the basic formula: is some offset plus the cycle length, some multiple of the cycle length, which slightly smaller notation here. And then the equation that we need to solve is so that we have offset 1 and cycle length 1 times I, and then you see that I is common across all of these, and here I say ON, so we have, n cycles, but actually we only have 6, and we need to find the I that satisfies all of these equations.
I would also argue that the problem can be broken down. If you can find I for O1 and O2, or for cycle 1 and cycle 2, that is the minimum I that will satisfy both of them. So you can take that result and play the game again with the result and the third cycle. And then you will get the minimum I that satisfies all three of them. You get the result and you play the game with 4. So what I'm saying is you don't have to do all of them at once. You can do them 2 by 2.
Yeah, that's true. But that's true. And what I thought was, instead of solving this equation, I think we do need to solve this equation, basically, which is finding the lowest common multiple of two numbers with varying offsets. But if we had no offsets, then it would just simply be this, which is the lowest common multiple, right?
Yeah.
So what I tried to do is brute force it and just generate the first 10 million or whatever. 10 million end offsets within end nodes for each cycle data. And then put them all together, and then just check if they all have the same value. And if they do, then we can print out the answer. As it turns out, these numbers are just too big, and I actually I don't get an answer. I do get the answer for our example, by the way. It does work for the example.
Good job.
But it doesn't work for the for the real deal. So I did take a sneak peek at how you do the LCM with an offset, and there was some mention of Euclid's algorithm.
No, that's for computing the LCM, the GCD.
Yeah, for the GCD, but somehow they managed to modify that. I didn't read too much into it, but I do remember studying that algorithm at some point, but in cryptography stuff, which I'm sure you're very familiar with. But I didn't look much further into it, but maybe there's some inspiration we could take from there. But it seems like it's too much to brute force. But that's where I'm at the moment.
Sounds good. In fact, I was thinking that perhaps the way to go here is to implement Euclid's algorithm from scratch, because I saw that in your implementation you're importing it from the mathematical library in Python. When we implement that from scratch, there may be some insight into how this can apply with the offsets, because the whole multiply the two numbers and divide by the greatest common divisor sounds intuitive to me as a way of finding the least common multiple. But if we modify Euclid's algorithm, then something may just fall out naturally. But all of that said, we have been chatting here for 40 minutes. I propose that we stop all this. We try to do day 11 because it may be easy. And get back.
All right. Whose turn is it to drive? Should we flip a coin?
I think that you were the last to drive, right? Because you were doing problem 10.
All right, you go then.
The labyrinth, the maze, the pipes. So
sure.
I suppose this is gonna be me driving. So
all right.
Okay. Day 11, people. We are taking none of that. Comic expansion. Bam. You continue following signs for hot springs and eventually come across an observatory. That kind of observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He will even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up? The researcher has collected a bunch of data and compiled the data into a single giant image, your puzzle input. The image includes empty space and galaxies. Okay. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from the galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should actually be twice as big. In the above example, these 3 columns and 2 rows contain no galaxies. These rows and columns need to be twice as big. The result of cosmic expansion therefore looks like this. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. In these 9 galaxies, there are 36 pairs. Only count each pair once. So 36 pairs is 9 chooses 2. Is that right? What is 9 chooses 2? It's 36, okay. Only count each pair twice. So if 1, 2 is a pair, 2, 1 should not be counted. Order within the pair doesn't matter. Okay. For each pair, find the shortest path between the two galaxies using only steps that move up, down, left, right, exactly one dot or hash at a time. So we are finding the Manhattan distance between the galaxies. Manhattan distance. Manhattan distance, taxicab geometry.
Is this the, like, sort of the outline?
Manhattan geometry, Manhattan distance, Manhattan length. I think that this is the fancy name for what we are looking for. But
Wait, can you look at some images for Manhattan distance?
Yeah, the images here don't really help, do they?
Go to like, Google Images.
That helps. So, taxicab geometry versus Euclidean geometry. In taxicab geometry, the red, yellow, blue, and green paths have all the same length of 12. The red, yellow, blue, and green. The green one is surprising to me. In Euclidean geometry, the green line has length blah blah blah, and is the unique shortest path, while the other paths have the longer length of 12. Okay, so the green one is kind of the Euclidean distance, but all the other ones are the Manhattan distance.
But if you go to just Google Images for Manhattan distance, I seem to remember it. Images.
Yeah, this is it.
Ah.
All right.
Okay. So Manhattan distance is like the up down distance. Is that right?
Yeah, you can take up,
or
down, left, and right,
taxi.
but you cannot go across because you are in Manhattan. You cannot go over the buildings. You have to go through the streets. So here I am on the 5th Avenue, and then I take a right, and then I take, you know?
I guess it's the same as taxi cab geometry then.
Yeah.
Manhattan. But that's nice. That's really cool.
And as it turns out, the distance between A and B is simply the distance at the bx minus ax plus by minus ay. It's that simple.
Yeah.
Taking the absolute values, of course.
Yeah.
The shortest path between two galaxies is allowed to pass through another galaxy. Good. Good. I didn't want to have to avoid galaxies, though part 2 is coming. For example, here is one of the shortest paths between galaxies 5 and 9. So again, we cannot go across, so we have to go down and right, down and right, down and right, down and right, down and right. And we could also have gone just down, 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 right, and it would be the same distance. Let's prove that this is the case. Here is 1, 2, 3, 4, 5, 6, 7, 8. It's confusing to me that they use this symbol to represent the path, given that it's already the symbol for a galaxy. But it is, I counted 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this path has length 9 because it takes a minimum of 9 steps to get from galaxy 5 to 9. I guess they're counting the final step as well. The 8 locations marked with the hash plus the step onto the galaxy itself. Here are some other examples of shortest paths. This will be useful for testing. In this example, after expanding the universe, the sum of the shortest path between all 36 pairs of galaxies is 374. Expand the universe, find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? And what does the input look like? Very reasonable. Very reasonable. So brute forcing is the way to go. Let's start with the expansion. And since we learned last time that it is better for me to be
share,
for me to be sharing since I am driving. That's what I'm gonna do. Oh, see? This is the shell in which I was running. There were no outputs, but it stopped the process.
Okay, well, it would have been much worse if you if there was an output and we lost it.
And this was my attempt at number 10. So we are going to look at this later.
Okay, cool.
I'm not even sure I should have committed this part because it was an experiment.
It's okay. All of my code in this repo is an experiment.
Let's start with the expansion.
You didn't share it with me yet.
Oh, right.
Internet's really good today, by the way. It's working nicely.
Excellent. So perhaps it's a matter of me being close to the modem. Yesterday it was in the other room. Let's start by expanding. The expansion will be... Well, no, let's start by parsing the inputs into a grid. So this is gonna be our universe.
I think you didn't press send in Skype.
I did.
Huh. Send again? I didn't get it. Okay, got it that time. Wow, missing messages in Skype. Anyway.
It doesn't really matter to do this second split because we could index into the string. We saw that yesterday, but I'm gonna do that anyway. And I'm gonna console log the universe. And it looks about right. Then let's expand the universe. And to expand the universe, I want to do this in 2 steps. I want to first detect the lines that I want to expand, lines being either rows or columns, and then I'm gonna proceed and actually do the expansion. So I will have my rows to expand. No, I want this as a list. And for those wondering, why am I doing this in 2 passes? It's because if I start manipulating the universe while I'm traversing the universe, I have to think about indices moving about as new lines and come in, and I don't want to think about that. So I'm gonna do the rows to expand and the columns to expand. Then I'm gonna apply them from right to left or from bottom up, and in this way I don't have to think about indices moving about. And that's why I have them as lists instead of sets. And I will be traversing everything from the top left to the bottom right, and then to expand I will do the bottom right to the top left. And expanding rows doesn't affect columns, and expanding columns doesn't affect rows, so I should be good. Now let's start with the rows. For every row in the input, which is every line, which is just input dot map, or not even that, I would just for const row of universe. But I also want the index, so I guess I will universe keys, and this becomes the row index.
You can do entries, by the way.
True, but I guess I'm gonna do the coordinates. So perhaps this will become the y's to expand and the x's to expand.
Oh no. Okay.
And then,
but you know, entries gets you the row and the
I know
thing.
Yeah.
Okay.
But
okay.
I like the way that universe y
works.
X
Yeah. Okay.
leaves.
Okay.
So because it's one single name to keep track of. But what I want to do
fair.
is and now it will pay off the fact that I split on the lines, because I will have some functions that work on lists or arrays that don't work on strings. For instance, I will have universe y dot every, and every, what do we call this, a cell? And if that is the case, then my y's to expand are gonna receive the y.
Yep.
Similarly, for universe at 0 dot keys. These are gonna be my axes, and if it is the case, this is not gonna be so neat. I'll have to do the long form. For const y of universe keys for blah, if I'll have to start with something like should expand is true, and if it is the case that xy is different from a dot, then should expand is false, and in the end, if should expand, then axis to expand receives this x. Let's see what we have here.
So y's are rows. The reason I find x and y is confusing is because y's are rows, but I always think it's y is vertical.
Y is indexing into the universe first, yes.
Yeah, but y's to expand are rows to expand, right?
Correct. I want to expand y number 0, 1, 2, 3.
Yeah.
And 4, 5, 6, 7. So I expect this to be 3 and 7. And I want to expand the axis, and that's a bit harder to read, so let's make a cursor here. 0, 1, 2, 2. I want to see 2 in the output. 3, 4, 5. I want to see 2 and 5 in the output. I want to see 2, 5, and 7, I think, or something like that. 2,
I think you could
question mark.
I think you could make it into an every, by the way.
Well, I would have to form a list of this.
If you made this universe.keys.every on that line, if universe,
yeah,
then it would work, I think.
Yep, you are right. The good old assignment to a const. And then I get 3 and 7 and 2, 5, and 8. I'm happy.
Nice.
So with that, I can...
I guess you could have just checked the description rather than calculating it, but yeah.
Yeah.
Nice.
So now for my const y of y's to expand, I will reverse. I want to see them from the last to the first. And now I'm going from the bottom up. And now I am going into the universe. And I will be adding an element in the in the middle. So I think that's a splice of... Is that a splice?
Yeah. To insert, you have to use splice.
And then there is a delete count, and then
which is 0. Yeah.
Okay, so I will take my y, a 0, and a dot that repeats for universe at 0 length. And if I did all that correctly, when I print the universe again, I should see some rows expanded. And oh, I just put a string there. No, it should be... Can I repeat an array? Is that a thing? No, it's not. I'm pretty sure it isn't. No, it isn't. So I'll do it the other way, which is a new array of size that filled with dots, like so.
You can do string repeat, and then you could split.
I could. You are right, but I didn't.
I didn't. I haven't used that before, so just wondering where you got the repeat from. Cool.
The universe is kind of hard to read, so I am going to create an auxiliary thing here to print the universe. Maybe something like JSON stringify with undefined and2 will do.
It does kind of make me nervous inserting into something that you are iterating over.
Well, but that's all right because...
Oh, you're not iterating over it, are you? Something else.
Yeah, I'm iterating over a list of indices. That's why I did this in two
classes. But won't the index change once you insert it?
No, because I'm going from right to left.
Ah, that's very smart.
Okay. So this is the resulting universe. I should see new lines in here, and I do see 2 lines in there. Then I should see a new line in here, and I do see 2 lines in there. That seems to have worked. Now let's do the trickier one. And for that, I will need to visit every line. So I will do a for const y of universe keys. And inside I have an array, so I will say universe dot at x dot splice at x0 dot, and I suppose that will do it. Let's check. So the first line has a universe, the second line has a universe, the third one should have some new stuff, and I think I see that. Then there are these 2 lines, and then there should be another one of those, and I think I see that as well. And then there are these 2 lines, and then there should be a new one. I don't see this one. Maybe that one didn't work. I'm doing this here because then I can have a multiple cursor thing going. So this has a universe, this has a universe, and these 2 have been copied successfully. This has a universe, this has a universe, and these 2 are correct. This has a universe, this has a universe, and then these 2 are correct. Okay, I got it. I got it.
Okay.
We expanded the board, everyone.
Cool. Yeah, nicely done.
Thank you.
The reverse was a good thought to get in early. So yeah.
Now, let's find all the universes and their coordinates. So I'll have my coordinates, which can be a set. Then I will traverse the board. So for const y of universe keys, for const x of universe at y keys, if universe at y at x is equal to a galaxy, or maybe I should say galaxies, or galaxy coordinates, galaxies coordinates, yeah, I like that. Push X and Y. Excellent. So what are my galaxy's coordinates? It's add. Let's see. On the expanded board, so I suppose it would be helpful to actually have it here. So I have one at 4, 0. So that's 0, 1, 2, 3, 4, 0. Then I have another at 9, 1. And that seems about right. And then, yeah, I'm happy with these results. So now I want to get these galaxies pairwise. So if I get the first one, I want to pair it with all the following ones. If I get the second one, I want to pair it with all the following ones. If I get the third one, then I want to pair it with all the following ones. And this way, I'm guaranteed to see every pair, but never repeat. So
yes,
I will leave this console log, and for const of galaxy coordinates index of galaxy coordinate keys. This will give me 0, 1, 2. Oh, wait a second, not keys, because that's a set. So maybe I'll do this with a list to keep things easy for myself here. And this way I get the keys. And then I will have another for loop. So this is going to be galaxy coordinate index A.
I'm excited to see how you're going to do this without recursion.
And then a galaxy coordinate index B equals the index A plus 1 down up to my galaxy coordinates length.
Yeah.
And then plus plus. So now I have my two galaxies.
Yeah.
And my two coordinates. So I will compute my distance. Or maybe I would just compute the final answer. So this distances sum starts at 0. I print it at the end. And thank you. As we mentioned before, I take my galaxy B, Y, or X, doesn't matter, minus my galaxy A, X. I take the absolute value, add to pretty much the same thing for the Y coordinates. And that's not a number.
Did you do dot X and Y? Yeah, you did.
I need to index into my galaxy's coordinates.
Oh yeah.
And that's 374. And the answer should have been 374.
Boom. Very smooth.
Well, we'll see about that, David. We'll see about that.
I think,
I trust no one in Advent of Code.
Well, part 2, yeah. We'll see. But that's great for part 1.
Yay!
Very impressive. Yeah, that was like record time as well. How long did that take you?
Thank you.
Not even 5 minutes?
I have no idea. I have no idea. But we are speedrunning this because we are trying to get back on track. Part 2, everyone! But let's celebrate the gold star. Yeah, the gold star was a good one. Thanks, David, for the nice words. I appreciate that.
Very cool.
The galaxies are much older and thus much further apart than the researcher initially estimated. Now, instead of the expansion you did before, make each empty row and column 1 million times larger. That is, each empty row should be replaced with, I guess this is going to be 1 million, okay, empty rows, and each empty column should be replaced with 1 million empty columns. In the example above, if each empty row or column were merely 10 times larger, the sum of the shortest paths between every galaxy would be this. So in the same example as before, if it was 10 times larger, it would have been this number. If each empty row or column were merely 100 times larger, the sum of the shortest paths would have been this. However, your universe will need to expand far beyond these values. Starting with the same initial image, expand the universe according to these new rules, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? I suppose my strategy for this one is, instead of literally expanding the board, because we know that's not going to go anywhere, instead of literally expanding the board like so, what I will do is, I will not expand the board at all. I will see when computing the distances if I have crossed any of those expanded lines, which I have neatly computed here, very convenient. And then if I have crossed those lines, I will add, I guess not a million, but I will add 999,999, and that should give me the numbers. So instead of, I will start modifying codes. I will copy and paste this, keep this as part 1, and call this part 2. Let's comment out the expanded thing here, or the big thing there, and then I will compute but not use. I will get my galaxy coordinates all the same, and I will compute my sums differently. But let's start with this to see if I broke anything along the way, which I didn't do, I think. But anyway, input is not defined. It's a matter of uncommenting this. Okay, so this number doesn't mean anything to us, but we will have another thing, which is our expansion factor, which should be 2 to begin with, because my intent is to rework the problem in this different manner and try to get to 374. Then I would change this number, expansion factor, from 2 to 10, and I should see this, and from 10 to 100, and I should see there, and then from 100 to 1,000,000, and I should have the final answer.
Yep.
So, over here, I will want to, I can be cute and smart and use the Euclidean distance, and also check for containment in these things. I think that perhaps now that we are more interested in containment than in iteration, it makes sense to use a set. And I will print this.
But don't you, all you need to know is the if it's like inside a range, right? But yeah, that's true.
Okay, 37258. I didn't break anything along the way, and so really the crux of the problem is now these 6 lines or 7 or 8 lines. So easy peasy, people. We are doing this. I will want to add. Let's start by thinking about the lines. I will want to add 900, or I guess the expansion factor minus 1. So expansion factor minus 1 times...
Are you sure about this -1?
I am, because the expansion factor of 2 turned each line into 2 lines. I already counted one of the lines, so now I need to subtract 1.
Okay.
And now I need to know what is the length of the intersection. Oh, there is no easy way to do set intersection now, is there? Is it time for me to import Lodash?
We'll try it.
It absolutely is. It absolutely is.
But Google intersection for JavaScript first. Is there no way?
Can we parallelize that? Can you do that for us?
Yeah, sure.
Thank you.
There is a intersection method on set.
Wait, what? Really?
Yeah.
Oh, that's fantastic. It's experimental, but I hope it exists in Node.js.
Oh no. That's annoying. Even on version 21.
It only exists in Safari. Oh well.
Oh. Okay.
That's alright, people. So I want the Lodash intersection between the access to expand and the Lodash range that goes from the minimum between I want them to read A and B like so, and the maximum between these two. Now there is of course a possibility for an off by 1 error here, so let's see how Lodash behaves in that capacity, or just check the docs real quick. It stands to reason that it's going to be like Python. Creates an array of positive numbers, or an array of numbers progressing from start but not including n in steps of 1. Perfect. Now, is this what I want? Well, it doesn't really matter, because on this line there is a galaxy. It will not be expanded. And on this, there will also be a galaxy. So it doesn't matter if it's inclusive or not, people. No off by 1 mistakes here. And this intersection will be... The access to expand are a set, but Lodash wants to work with lists, so I'm gonna backtrack yet again. And then I'm gonna do the same for my Y's to expand. And, ooh, wait a second. I forgot to put my X's here.
Oh, you need to index. Oh, you need to access it. You're just using indexes still.
No, but this time that's what I want. I am interested in the coordinates, not in the values in the coordinates.
But that's still the index?
No, you are right and I'm wrong. Thanks.
Might be easier to read if you move that indexing out, but yeah.
No. 374 people.
Is that correct?
That is correct. Now let's change that to
Wow.
10.
Oh yeah, of course, yeah.
1030. Now let's change that to 100. 8410. Now let's change that to this much. Do we need to deal with big ints? That's the right answer, everyone!
Hey.
Success! So with that...
On fire!
Thank you. With that, we are only 1 day behind because we have 2 halves of problems to solve. Do you want to invest a little bit of time on the pipes, or do you want to invest a little bit of time on problem H?
We're still 2 behind, right?
We are 2 halves. We are 2 day number 2s behind.
Oh, I see. Yeah. I want to do the pipes because I know what I want to do.
And you are driving, so take it away, David.
All right, cool. Are you still in? You're not in my old one, I think.
I removed myself from that because I wanted to.
Okay, let me create a new session because.
Yeah, I wanted to minimize the use of the internet here. And while you're doing that, I am doing some bookkeeping here. Did you share the link?
No.
And David is here commenting. I will read all of this more carefully after the stream, but it was pretty funny to see the 2 of you yesterday, but I've been there. When you don't see it, you just don't see it. But the text states every pipe will have just 2 connections, so you can never branch. And the start also adheres to this, so no need to guess. Yeah. I think we finally got there. It just took us a little more time. If you determine 0, 0 is not part of the loop, just look if you touch that with the flood fill. Yeah, that's pretty much what David is doing. Oh man, I should show you mine. It's actually animated. You can quickly see it here. Okay. Just mute it though because I don't want to spoil anything. Yeah, that's why I'm not even gonna click on it right now. I'm gonna keep it for later. Sometimes even your animation can give something away. I'm going for lunch with my family for a bit. Here's my code for day 11 in case you want to take a look at it. And Not Was One is here. Hello. And I can take a quick peek at day 11, but I will not be looking at all solutions. But let's see what you are doing. Part 1. You changed the padding, you say? Are you telling me that you expanded the board and it worked? Because this time I didn't even indulge the brute force solution and you're telling me that this time it worked?
Yeah.
Ah, get out of here.
Oh man.
Alright,
funny.
David, I'm in.
Okay, so we want to be on day 10. I'm gonna check if I don't want to bother with these ones really, because it would just be cleaner, and I'm pretty sure all of them will have one. So let's just see if we get a first node. Let's try for my input. Do you want to paste your input at the top so that we can check yours as well?
Wait, you're asking me to paste?
Yeah.
Ah, okay, okay, okay. I had this tab open yesterday, and Abby saw this, and she was like, "Oh my god!"
You were writing the Matrix? It's not completing. It's not even getting to that step at the moment. I'll just wait for you to paste that in.
Okay, it's in.
So part 2. Let's see, did we get the path? Yeah, we get the path. Okay. How many outsiders do we get? Get the outsiders, and then I think I like changed the line, and now it's like an infinite loop or something. Hopefully that's the reason this is failing. Outsiders, and then okay, this is not completing. So maybe we're not finding any. Wow, but it should at least just say like first node not found. This is for every path in the cell, of which there are 13,000. It's checking, it's getting 4 different cells, and it's checking if it's this.
Could there be any shenanigans in terms of mutation? When you move, you are actually mutating the cell or something like that?
No.
Okay.
I'm not mutating the cell. But I mean, is this getting a lot of times here? No. That doesn't make sense. Is it this redefinition of node is not working? No. Huh. I don't know why. It's simply not... Is it even getting in here? Let me just try calling this... It's not to do with that.
I feel so lucky that day 11 was an easy day.
Well, yeah.
Compared to this, and especially to day 8 part 2, day 11 was a walk in the park.
Yeah, so for whatever reason, it's not getting to this line. It's not getting past outsiders. Can you see something wrong with the program?
No, because unfortunately I don't have it in my head. I'm still reading it line by line, not chunks at a time.
Oh, sorry, it's not getting to this line. It is stuck in an infinite loop here. That's fine. So it's this code here which is stuck in an infinite loop.
Well, the open list, is it ever getting popped? It's pop 0. What does that mean?
That means pop the first one.
And when we append, are we ever removing and appending the same thing over and over? Is there any notion of the next cell has already been visited or something like that?
Yeah, next cell is not in path and it's not in outsiders.
Outsiders being it has already been visited.
Yeah.
Okay.
Let's print out. Oh, also I'm calling outsiders. But let's print the outsiders. Oh, it's not very helpful, is it? Well, we can print the length of the open list and the length of the outsiders. See if that. So the outsiders continues to grow.
It's too bad because I cannot see our terminal anymore, but I'll just trust you on that one. The terminal stopped working like it sometimes does with LiveShare, but that's alright. So the numbers are always growing.
The numbers are always growing.
Is there a problem with the set containing two, let's say, outsider is a type of coordinate or something like that? There's a class called coordinate or something like that, and then two elements of that class are not compared by equality but by identity, or sorry, not compared structurally, but
that will be it.
Okay.
Yeah. So what it's finding in Excel. So move returns an optional cell, and a cell has this for comparing itself. This should work.
Can you prove that to me? Can you create like new cell equals new cell or something like that? Or maybe put two of them in a set?
Yeah, so it says true and the set is length 1.
Perfect.
So that definitely does work. Let me just double check again. So open continues, the open list continues to stay the same size, but the outsiders continues to grow. But outsiders are...
Are you checking the boundaries of the board?
I am in move, so it won't return cells which are outside of the board.
Okay.
But what I'll do is I'll print cell. Yeah, it continues to add these.
And they are all different.
I mean, I suppose so. Should we try with a smaller input? Sorry. Yeah, so it works for a smaller input. Which is annoying. Pretty annoying. It terminates eventually. Maybe there's something fundamentally slow about this.
So it's not the issue that it is throwing an exception, running out of memory, anything like that. It's just taking very long.
Yeah, although it never gets to this line like while I'm running it, which for me it seems surprising because it's not that big a list.
Yeah.
That's like way too slow. Unless there's like something really slow going on. Oh no, it did finish. So.
Okay, so it just takes a little longer than immediate, but that's all right.
Yeah, I guess I was just a bit impatient. Huh. Although now that I stopped printing, okay, now it went. Yeah. And now it's just printing a shitload of stuff. I think it's actually, it might have been printing all the other stuff was like blocking the buffer or something, and it was like not being flushed. It was like all of this debugging at the bottom here, which was slowing things down. Maybe not. No, it just takes a decent amount of time to do that. Isn't it super slow? I don't see why it's so slow, but anyway. Now I just need to get rid of my prints, get rid of that print, and get rid of... oh, there's some other prints. There are some somewhere. There. Okay, so we do get a first node in my input. It takes a long time, and but that's fine. We're not going to use the main input, and I'll just double check that we also get it for yours, and then that way we can keep operating with this code.
Thanks for taking care of my inputs as well.
No worries. Yeah, we also get a first node. Cool. So let's go with this. Let's go with this example because it's pretty tricky. So I can delete this code now. So you're clear on what we're doing here. We're finding a node which is on the connected to the outside. So now let's change this node to we want to walk along the path and fill anything unmarked. Right?
Mm-hmm.
So we will start on our first node. And then I'm gonna add all of the path to the insiders already, and then I'll pop off a node, and we want to get the next. We need to get the character and the direction and the next cell based on our previous direction. Is that all correct? Yeah. And then now we need to construct the next node based off of that with the correct inside and outside. So next cell, previous, and now the inside and outside. So, we actually call it the outside. So the outside. Should we go with the outside or inside? What's easier? So if we do inside, then we have to do like all of the I've started with outside. It should be fine. So the next node so if the character is one of these, and the direction. Is left, and it's one of those. This is the tricky bit. And no dot outside. I might need to draw some diagrams. Is up, then next outside is left. If I can do one case, then I should be able to do the other cases. Let's do it very explicitly, so I can be like super. I mean, I'm sure there'll be a simplification, but so if the like, yeah, if the node dot char. I'm not storing the char. I could store the char. Should I store the char? I'm not sure I'm going to need it.
Draw a diagram. Let's go to ExcaliDraw.
Yeah, let's go to ExcaliDraw. Okay. So I'm on this one. And I've arrived here. Then if I look at my character, if this is another hyphen, and I know that the previous outside was there, then I know it must be above. And if I'm here, well, I know it must have come down. Well, yeah, so if I came left and it was above. If I went down and it was above. Is it if I went horizontally? If I went vertically? Does that help? If I went horizontally and it's above, I guess I should just do some cases, right?
Go ahead. So taking a step back to recap, what we are doing now is we already have the blue. We know that one of the sides of the pipe is the exterior. Then we are now following the path and trying to keep track of what exactly? I forget, or I don't really understand.
Well, we want to keep track of the outside and the inside because we want to label all of these, right? So we just need to, when we transition, we need to keep track of what's on the outside and what's on the inside. That's all.
Okay, so you're trying to find everything that is on the outside.
Yeah, exactly.
Okay, and once you do that, the idea is going to be the interior is everything in the board, the size of the board minus the outside minus the number of pipes.
Yeah.
Okay.
And we're only going to travel left and up. I don't know why left. Let's change it to right and up because left is annoying. I mean, at some point we may be obliged to turn the corner. So we've got this. We'll always start with why does he keep doing that? One of these. So if it's transitioning right, and the previous one was a dash, and this one was a dash, the issue is that this one could be one of these. So now the outside is not just on the...
So there is not just like one outside node. There are, I would say, 2 or maybe 3, depending on whether you want to do diagonals.
Yeah. And also it could be like, well...
But there is something I don't understand. What is the purpose of doing all this if we have already seen that, let's say, we see that this one is on the outside, and we have determined that that is on the outside. Why don't we just flood fuel and then we get all of the outsides without having to do the traversal of the path?
We have done all of the outside, but there's going to be, if you look at this example over here.
Excuse me.
If you follow.
Okay.
This example over here, we can't just traverse the outside.
True.
We to get to this one. So we need to traverse the inside, the loop, to populate this outside bit.
Mm-hmm.
And
how will that so far, all that I've seen in your drawings here are that you already have a blue region and you're trying to carry it along. What is the point in carrying it along if there will be a discontinuity in the outside anyway over here?
Because if all we need to know is that, like, yeah, there will be a point where this, like, there becomes a discontinuity, right? There's no outside labeled here.
Yeah.
However, because we know that that's the outside, it's going to be easy for us to label it as the outside.
Well, so in essence, what you're telling me is that the only piece of information that you need to keep is literally one bit. You need to know when I am doing my path traversal, when I'm following along the path, is the exterior to my left or to my right, and that's all.
Yeah. Well, to your left or to your right. Obviously, if you're on this corner one, you need to know whether it's like left or right is kind of not. It's a corner, so
well,
you need to.
No. It's not just a corner. It's not just a corner. We don't have just a path. I'm saying, given a path and a direction in which to traverse the path. So let's say I am in a path and I'm going up, then exterior is to my right. A corner doesn't change that property because if you look at this arrow, the exterior is still to the right of the arrow.
Yeah, exactly.
So given a path and a direction, the exterior is going to be the right or the left, and that's all you need to know. And it will cover even the case of discontinuities, because there may be a discontinuity, but the outside will always be to your right.
That's true. Let's go back to the code then. So we can simplify this. And the outside is just a string. And that means that if we are traveling up, so if the outsider is up and we start traveling right, then it's to our left. If the outsider is down and we're traveling right, then it's to our right. If we're traveling up and the outside is to our left, it's to our right. Sorry, it's to our left. And then it's to our right. So it's literally left or right. Like that.
Mm-hmm.
Now, when we move to the next to the next cell, it will still be the next node. It will still be whatever the previous one was, right? So
correct.
it'll be...
It is always the property of the exterior is to your left or to your right is a property of the path and the direction you're taking, not a property of nodes in the path.
Right, correct. So, and actually we could probably just keep the outside as a separate variable, but that's fine. Now we have the next node. We need to label everything on the inside and label everything on the outside. So if we're on this one, on the right of this is this and this, because it's got two directions, right? It's the direction that we arrived in and the direction that we are leaving.
Mm-hmm.
And the same for the inside. There's the direction that we're arriving, the direction that we're leaving. So, we need to...
I realize my mistake now. In your explanation right now, I realize what I did wrong in my implementation. Because remember, I said I implemented this and it worked for my small examples, but it didn't work for the full example. I know what the problem is. I was always thinking that I could just work on the 4 cardinal directions, because if I arrived here, I would be able to get there by just flood filling. But there could be a path that looks like this. Where this is the interior, and there will be some twists and turns, but this is the interior, and this is exterior. So when doing turns, and in this case, everything involved here is a turn. This is a turn, this is a turn, this is a turn. All of those are turns. Okay? I need to not take, when doing my, what I call the nodes to explore, I need to not only add the cardinal, the 4 cardinals ones, I also need to add the diagonal one. Because it could be the case that the exterior is sandwiched between these joints. So that is why my answer, the way that I computed it, I am not computing the exterior and then subtracting, I'm computing the interior.
Yeah.
So I guess just reverse all my explanation, because I am computing the interior. So red is now the interior and green is the exterior. But I was not counting this interior. And my answer was indeed below the correct one.
Yeah, and actually that makes sense. I also have to do that probably. And the way I was thinking about it, getting at this one and this one and this one and this one, that could miss these corners that you're talking about.
Yep. So I think I found the edge case that I'm missing for my solution. And in terms of logic, it's the same as your solution.
Okay, so I guess I need to get all the cells around it. So this is for just getting the next cell, so I'll leave this down here. So for processing this cell, get all the cells around it. Label whether they are inside or outside, and then flood the inside or outside. I think I only need to, I guess it doesn't matter whether I flood the inside or the outside. I can get that slightly easy bit. So get all the cells around it, so I need to say cell top, cell top left. Yeah, I'm gonna need to change this to be top left Is that right? Yes. Yes. Top right. Bottom left. Oh no. Now they're all... I think I need to do this as up right and up left. Oh dear. Maps. Down left. And... down right. And did I miss any? No, I don't think so. Okay. And then let's jump back down and oh, actually, it had a pretty nice way of doing that. Copilot solved that for me. It put in the cell top. Kind of smart.
Okay.
I guess I could do it that way.
Cute.
Yeah, I kind of like that. I'm going to do that. I'll do this. I will call it up, though. Upright. And then left and right. Yep, yep, yep. Okay. So, if, now how do I work out which one is which? If I'm going up and it's on my right, then it depends on the character still, doesn't it?
I find it dangerous to look at the characters at this point because of the edge cases. There's the S, which is an edge case. There is the fact that there may be junk around your path.
But we need to know...
My intuition tells me that after you have determined the path, you should not be looking at the characters anymore.
Well, we're always guaranteed to have two which are on the path, right?
At least two, yeah. No, at most two.
So,
at least two. At least two.
Yeah, always two.
No, there may be more because there may be the path may be doing the serpentine thing, and then you will see parts of the path to your left or to your right, but they are not the next step you're gonna take.
Yeah. That's why I think I need to know the character. Because if it's maybe let's do some easy cases first with the character. If the character is this and outside is on the left, then insiders.add cell right, and outsiders, not discard, but add cell left. Is that true?
That seems correct to me.
I don't think it's always guaranteed that on my left it's an outsider.
Because it could
Or
just
is
be
that
a
true?
serpentine coming back.
Yeah. But it's always guaranteed that the inside is
Not even, because it could be a serpentine on the right, and it's part of your path. Or are you considering that your path in and of itself is inside?
yeah, the path itself is inside.
Okay, then.
Always. So maybe it makes sense instead to say, look, always, yeah. So if the outside is right, this is fine. We only need one of these, right?
Okay.
L if char equals this. Right. Then that makes sense to me.
Okay.
If it's on the, then it should be. If the outside is on the left, how could the outside be on the left? No, that's wrong.
No, the outside will be. The outside is. When we say outside on the left and on the right, even for the pipes, line 523 and 525, even in this case, are we traversing the pipe going up or are we traversing the pipe going down?
We are always going up or right.
So if you are looking at a pipe in isolation and saying, I'm always going up on that pipe, then, okay, I see what you're doing. It's not the way that I think about it, but I understand it now. So, yeah, then the outside would be either up or down. And then in this situation, it is true that the outsideness of a region is a property of the node, because you're looking at the node in isolation, while I wasn't. I was looking at the node with respect to the direction that you're traversing it.
Yeah. Yeah. And because we always start in this region here, we always start in to the right or up. I can always think about it that way.
Okay.
Now, this is the slightly more difficult. I'm sure your solution is much more elegant than this. But so if the char is, so what are the other chars? Let's bring them in. In fact, there's just these pipes.
I think it's time for the cliffhanger, David. I think it's time for us to continue tomorrow. Yes.
Okay. Well, perhaps I'll finish this one off so that I'll put you out of your misery.
Well, this part is kind of mechanical, so yes. But
yeah.
And I may add the breakthrough that we had together here to my solution to see if that works as well. But other than that,
yes.
Are we meeting again tomorrow at 10?
Yes,
all right.
Absolutely.
So,
all right.
Let's see if there are any last comments for us to look at. And no. So at this point, it's just me thanking Nick and Not Was One for joining us on the chat. Oh, and Bo for joining us on the chat. And thank you to everyone else who is watching this in the future. Thank you very much to David for coming up with this project idea, this crazy idea of doing Advent of Code. And I'm looking forward to seeing you again tomorrow at 10 a.m. UTC. Have a good one, everyone.
I look forward to it too.
Bye.
Bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.